Hello, students. Welcome back to Unit 2 Basic PLC Programming. In the last session, we saw given a logic circuit how to convert into equivalent ladder diagram. In this session also, we'll see few more conversions. So, given a logic circuit, how you can convert into ladder diagram and vice versa. Given a ladder diagram, how you could convert that into a logic circuit. So, few more examples on these conversions we'll see in the today's session. And from the last session, we'll recap that when you have an AND gate, the inputs of AND gate are represented as contacts in series to get a ladder diagram. Similarly, the inputs of OR gate are represented as contacts in parallel. And one more point is that whenever the input is inverted and applied as input for one of the input of a logic gate, in that case, the input is represented as a NC contact, normally closed contact. So these three were the basic concepts we learned in the last session. So we'll use the same concepts and then we'll go through few examples. So see here, I am giving a ladder diagram here. Convert that into a equivalent gate diagram. So here we have the contact 10 and it is written as normally closed in ladder diagram, and hence the state is inverted. The inversion is accomplished at the input of OR gate 22. So now you look at the ladder diagram here. You have 1 and 2 connected in series. So here 1 and 2, because these contacts are in series, it represents the AND gate inputs. So we have AND 19 gate, the input for that is 1 and 2. Similarly, we have 5 and 7 contacts, they are in series. So the series combination of 5 and 7 is converted into a AND gate. So you have AND 20 whose inputs are 5 and 7. Similarly, here we have the contact 10, which is NC contact, and 11, contact 11, normally open contact. So 10 and 11, they are in parallel. So this represents the parallel combination, represents the OR gate. So I have an OR gate here, OR 22. Here I have considered 10 and 11. Here for contact 10, it is normally closed. Hence, in the logic diagram, the input 10 is bubbled here. The 10 input is bubbled, which is the input, and then applied as input for OR gate. Now we have contact 8, this contact 8 and parallel combination of 10 and 11. 8 is in series with the parallel combination of 10 and 11. So series is always represented as AND gate. So I have taken AND gate 21 and 21 whose inputs are 8 and the parallel combination of 10 and 11. So individual parts are over. Now you see the combination of 1 and 2 parallel with 5 and 5, combination of 5 and 7. Similarly, that is in parallel with the third rung. Hence, this parallel combination is replaced by one more OR gate. So for that OR gate, you have the input coming from combination of 1 and 2, and second input coming from combination of 5 and 7, and the third input is coming from the combination of 8, 10 bar and 11. So I will take three input OR gate. So here I have taken a OR 23 So you could see here one combination, the first input is coming from 1 and 2. The second input is coming from the combination of 5 and 7. The third input of the OR gate is coming from the combinations of inputs 8, 10 and 11. And the output coil 15 is shown as the output of R23. So here I have written a Boolean equation also. Here you have 1 and 2 are in series. So that is represented as dot here 1 dot 2. Again 5 and 7 series. So it is 5.7. And we have 10 bar and 11. They are parallel. So plus is or operation. A plus is used here, and this parallel of 10 11 is in series with 8. So 8 dot of this parallel combination. And at last I am going to uh, or all these three inputs. So you could see here 1.2 plus is there, 5.7 plus is there, and then this will be the third input. So for an OR gate, you are having three inputs. Final OR gate, which produces an output 15. Now we'll move on to the next example here. Here, given a PLC ladder diagram, convert that into a equivalent gate diagram. So here I have taken the contacts. A ladder diagram is given to you, and convert that into a logic diagram. Here, one clue is that whenever you have contacts in parallel, replace that by a OR gate. Whenever the contacts are in series, replace those contacts by a AND gate. So first we'll solve the first line, first rung. We have P, Q and R. Q is normally closed, whereas P and R are normally open. So in that case, the input Q is negated by having a bubble, right? So P, Q and R, they are parallel with each other. So parallel combination, whenever you have parallel contacts, so replace it by OR gate. This is a clue. So you could see here we have OR gate A, and the inputs are P, Q bar and R. Since it's Q bar, it is bubbled at the input. Now we'll move on to the second parallel combination of U, V contacts. So because U and V are parallel, so replace those contacts by a two input OR gate. I have taken a OR gate B whose inputs are U and V, right? Then we'll go for the second rung. Here we have contact S and T parallel. So replace that parallel combination by two input OR gate. So here I have taken OR gate C. The inputs are S and T, right? Then we have contact Y, which is in parallel with, which is in series with the parallel combination of S and T. So this second rung is entire thing is now replaced by a AND gate, and whose input is coming from parallel combination of S and T, and the second input is coming from the Y. So I have taken AND gate D. You could see here it has two inputs. One is Y input, and this first input is coming from the parallel combination of, that is OR operation between S and T inputs. So the second rung is completed. Now go back to the first rung here. Here you see I have taken W and X. W is normally closed contact. So it has to be bubbled. This input has to be bubbled in the logic diagram. Here you could see here we have W and X. So W X as well as parallel combination of U and V and parallel combination of PQR. They're all in series. So this is represented as a 4 input AND gate. So I've taken AND gate E. You could see here it has 4 inputs. First input is coming from parallel combination of PQR. The second input is coming from the parallel combination of U and V. Third input is coming from input W, and the fourth input is coming from X. So this completes your first rung representation also. Now you see here, to produce the output Z, um, we have the parallel of this first line and the second line. So parallel is replaced by OR. So taken a OR gate F. So it has two inputs here. You could see here, and this produces a final output Z. And the Boolean equation is written as P Q bar and R parallel OR operation. So P plus Q bar plus R. Then we have U and V OR operation, U plus V. Then we have in between this, you have the AND gate input, 4 inputs. They are in series, so I put a dot here. You can see here dots. And the last line is SNT or operation, so it is S plus T. And that is in series with Y, so it is a dot Y. And all these combinations are OR together. So you have a plus operation here, OR operation, and this produces the final output Z. Next, I have given a logic diagram is given to you, a gate diagram. Then convert that into a equivalent ladder diagram. So this is simple, I believe. I have taken and one. The inputs are 101, 103, and 105. So AND gate is replaced by it is replaced by contacts in series. So I have taken 3 contacts, 101, 103, 105. They are in series. Like that, I have one more AND gate. The inputs are 111, 113. So since it is AND gate, it is replaced by series contact. So I've taken 111 and 113 contact. They are in series. Then we have OR gate or 3 whose inputs, it has 2 inputs and coming from AND operations. So this OR gate is replaced by a parallel combination. So this is one AND gate and this represents a second AND gate, and they are OR together, so they should be in parallel, and this produces the final output R. So looking at the Boolean equation, we have here 101, 103 and 105 inputs. They are ANDed. So its AND operation is dot output. Then we have one more AND operation between 111 and 113. So 111 and 113, in between that AND operation, a dot is put. Then these two ANDed um, terms, they're all together or operation, so that is plus here. Next we'll move on to the another example here. Okay, here a gate diagram is given and converted into a equivalent ladder diagram. So you could you see here I have a OR gate 1. The inputs are A, B, C. Since it is AND gate OR gate, It is replaced by a contacts in series. So I've taken ABC contacts in series. Then we have R2. The inputs are D, E, F. OR gate is replaced by a parallel contact D, E, F. Then we have AND gate. The inputs are G, H. And this AND gate inputs are replaced by series contacts. So it is G, H bar. And H is taken as normally closed contact because the H is inverted here. So it is H is taken as a NC contact. Then we have to produce a final output M. The three inputs are ANDed. So this AND is replaced by series combination. Hence, you could see here ABC, which is in series with DEF combination, and that is in series with G and H bar. And the Boolean equation is that here ABC, they are or together or operation, so it is plus is used. Similarly, DEF inputs are or together, so I have used a plus here. um, your G and H bar, they are ANDed, so in between this I've got a dot. And to produce the final output M, I'm ANDing the three combinations. So in between this combination and this combination and this, I have used a AND operator. That is a dot operator is used here. Next, we'll move to the last example. Here, a logic diagram, gate diagram is given. Convert that into a equivalent ladder diagram. And here, one more concept I have introduced here. You see here, R is the input, and this R input is applied at two different places in the logic gate diagram. So R appears at as input for two different gates. In that case, whenever I'm writing a ladder diagram for this input, in two places, I need to show the contact as R. R contact is shown in two places. So here, let's see here. I have OR gate 17 and the inputs are L, M, N. So this OR gate is replaced by contacts in parallel. So we have L, M, and N contacts in parallel. And since the input M is bubbled, it is taken as normally closed contact. Then I have the AND gate 18. The inputs are Q and R. So this AND gate inputs are replaced by contacts in series. So we have Q and R in series. And we have OR gate 19 and it has two inputs. One is coming from OR 17 and the second input is coming from AND 18. So this is OR and this is uh, your AND 18. So they are connected to a OR gate. OR means these two combinations they are in parallel. So I have taken L, M, N parallel combination and that is parallel with Q and R combination. So you could see here. And this produces the OR gate output. You have OR gate 19, that output is produced here. Here, one more thing you should observe at the output of OR gate is negated here or complemented. So in that case, in a ladder diagram, what I'll do is this output of OR gate is available here as logic 1. So it's the intermediate output, and So I'll take in the second rung, I'll take logic 1 contact. And since the OR gate output is negated, or the input of gate 20 is negated, so the logic 1 contact is taken as NC contact, normally closed contact. And we look at the AND gate 20, it has two inputs. One is the R, and the other input is negated. It is coming from the gate 19. So, and since it's an AND operation between these two inputs, these inputs are represented as contacts in series. So you could see here, I have taken a contact whose name is R, and you have the logic 1 contact. And because this is bubbled or inverted, it is taken as the normally closed contact here. So these two contacts are in series, which represents the AND gate 20. And the output of AND gate is yes. So this will energize the coil, yes. And we have written the Boolean equation also here. You could see here L m bar n. It's a OR operation, so plus is used here. Then we have Q R. It's an AND operation, or dot is used between these two inputs. Then we have we have R input, then Q dot R input, L plus M bar plus N. This is the third input. So all these three inputs and are given to connected to an AND gate. So AND operation is done between the three inputs. So you could see a plus here, sorry, AND operation. So you could see a dot here. And here I have put a whole bar here which says that the OR combination, that is the OR gate output is complemented. So I have put a whole bar here. After putting a bar here, and then I've ended with the last input R to produce the final output. Yes. So I think we went through a lot of conversion programs, given a ladder diagram, how you can convert it into a logic gate diagram, given a logic gate diagram, how you can convert it into a ladder diagram. So these are the few conversion problems we have worked out in the last two sessions. So these two problems were taken mainly because you need to, I mean, how the you need to know how the what are the equivalents for AND gate, OR gate, or a NOT gate. Okay, so these were very simple problems which involved only the gate conversions. So I think this will be the last session on Unit 2 basic PLC programming. Once we take up the next units, we'll be using the timers and counters because your practical applications are not just limited to these gates. It involves time limitations, then counting should be incorporated into the application. So in that case, we need to use a timer function and counter functions. So till this session, what we learned is only about the input contacts, then output coils. So in the next unit, we'll be learning more on how to use a timer function, then a counter functions. So which becomes more and more practical. Thank you.